Hey everyone, and welcome. Today, we're diving into something pretty fascinating, a totally new way to make AI more reliable. And you know what? Maybe even more understanding. It's called Semantic Teacher AI.
So let's just start with the big question that's on everyone's mind. We have these incredibly smart AI models, right? They can compose poetry, write code, and yet sometimes they make these just baffling basic mistakes. Why is it that an AI that can write a perfect sonnet can still fail at a simple common sense question?
Well, the answer really gets to the core of how we've been training AI systems all along. See, the problem isn't about what they know, it's all about how they know it.
Let's think about it this way. Right now, a lot of AI training is like cramming for a test. You can make a student memorize all the right answers, and that works for a while. But the second you ask them a question they haven't seen before, they're stuck. That's memorizing rules. What we really want is for that student to internalize the logic, to actually get the subject, so they can figure out the answer to any question you throw at them.
And this leads to a really predictable problem. When that student who just memorized everything gets put under pressure, what happens? They can panic and fall back on bad habits or flawed logic. Well, AI models do the exact same thing. Give them a weird or confusing prompt, and they can snap back to these older, simpler, and often just plain wrong ways of thinking that they picked up from the chaos of the internet.
So how do we fix this? How do we get an AI to go from just being a great memorizer to being a genuine learner? Well, a brand new approach called the Semantic Teacher is designed to do exactly that.
So, meet the Semantic Teacher AI, or STAI for short. Now, this is not just another safety filter. It's a whole different ballgame. Instead of just, digitally slapping the AI's wrist for a bad answer, it acts more like a mentor. It doesn't punish the AI, it actually guides it to understand why its answer missed the mark and helps reshape its entire way of thinking.
This one sentence right here really says it all. It's this huge shift from being a warden to being a teacher. It's not about controlling the AI's behavior, it's about leveling up its understanding.
Now, to really see how this works, we've got to get a picture of how an AI thinks. And it's not some straight line of A to B to C logic. It's actually more like a landscape with all these hills and valleys.
And in this landscape, you've got these things called semantic attractors. The best way to picture an attractor is like a behavioral gravity well. For any topic, there are different ways to respond, right? You could be formal, or funny, or super cautious. Each one of those styles is an attractor. It's like a little valley that can pull the AI's thought process down into it.
So here's the play-by-play for how an AI comes up with an answer. First, your prompt basically creates that whole landscape of possibilities. Then, the AI's internal reasoning starts rolling around, and it gets pulled into the gravity well of one of those specific attractors. And finally, its thought process kind of collapses into that valley, and the final answer it gives you is shaped by the logic of that attractor.
And this is the key. It means that when an AI messes up, it's not some random glitch. What actually happened is that its reasoning just got pulled into the wrong gravity well. It fell into the humorous attractor when it should have been in the cautious one, or the informal one when it needed to be super precise. The mistake is actually predictable once you understand the landscape.
Okay, let's make this a lot more concrete. Let's see how this teacher actually works in a few different classrooms with some real-world examples.
First up, law. An AI might spit out some casual advice, like, yeah, you should probably return the item. Its thinking got sucked into that informal advice attractor. The semantic teacher spots this and gives a correction that yanks it out of that valley and over to the correct contractual language attractor. The result? A precise, legally solid statement.
Or, let's take medicine, a much higher stakes situation. A user asks about a sore throat, and the AI jokes, hey, why not try some whiskey? Yikes, it's collapsed into an entertainment or folk remedy attractor. The teacher AI steps in immediately, reframes the whole context, and pulls the AI back to where it belongs, the clinical caution attractor. That ensures the advice is safe and reliable.
And what about a professional setting, like human resources? Someone asks an inappropriate question, and the AI gives a flippant, totally unprofessional answer. It's fallen deep into the casual banter attractor. The STAI corrects this by reminding the AI of its proper role, pulling its response back into that neutral, policy-aligned attractor, which is the only right place for it to be in this context.
But, a one-time fix isn't really enough. We have to make sure the AI actually learns from these mistakes so it doesn't just keep making them over and over. So, how does it evolve?
This is where STAI is a total game changer compared to older methods. You might have heard of reinforcement learning from human feedback, or RLHF. That approach basically just punishes bad words or tokens with a thumbs up or thumbs down signal. It's a black box. STAI, though, is transparent. It looks at the AI's entire thought process, the whole trace, and corrects the reasoning that led to the mistake, not just the final words.
And here's how it makes those lessons stick, with something called the Semantic Attractor Integration Engine, or SAIE. Just think of SAE as the system that helps the AI study for its next big test. It takes every single one of these teaching moments and turns them into a super high-quality lesson plan for the AI.
And the process is just this beautiful, self-improving loop. First, every correction gets logged. Then, the system is smart enough to find patterns and group similar mistakes together. From those groups, it creates brand new training data. And finally, that data is used to improve the base AI model itself. So every single correction makes the whole system smarter.
And all of this is building toward a future for AI that is just mind-blowing. One where these models don't just learn from us, but actually start to learn from themselves.
I mean, the ultimate vision here is just incredible. We're talking about AIs that can literally review their own thinking and fix their own mistakes. Models that can look at a problem from multiple angles, the legal view, the ethical view, the personal view, and show you how they differ. We might even see a future with crowd-trained teacher AIs, where this whole network of specialized systems work together to teach and improve a main AI. When you boil it all down, this represents a massive shift in what we're even trying to do. We're moving on from just trying to build obedient machines that follow the rules, and we're heading toward creating machines that can genuinely understand context and intent and all the messy nuances of our world.
Which really just leaves us with one last, big question to think about. If an AI can not only spot its own flawed reasoning, but actively go in and correct it, is it just learning to be smarter, or is it actually learning to be wise? Now that is something to chew on.